Hi, Stat Scholars. Hope all of you are doing well. Um, I'm going to try to make a video for you. I've finally I'm feeling better, enough so I can get up and make this video. It's been a rough 3 days really, where I was really sick, but now I'm feeling a lot better. Never had any problems, if you're wondering about this variant of COVID with me. Never had any problems with my, coughs or, breathing. But boy, did I sneeze up a storm. Woo. And I did test positive. I haven't tested again. This is like the first morning where I felt a little bit normal enough so I could get up and try to do stuff. Making this video for you from like this little room in the back of our cottage. It's kind of a utility room. I got to stay back here because I have my wife here. My wife hasn't tested positive. Don't start coughing, Mike. Now, my wife hasn't tested positive yet, so I'm doing my best to make sure she doesn't get sick. Yeah, and it looks, unless something changes, it looks like I'm going to be okay, and I'll be back in on my feet and working and back in school on Tuesday. Sorry we missed a couple days this week of lessons. The two lessons I had planned was measures of center and measures of spread. I'm going to cover measures of center with you today. It's rather easy. It's a rather easy topic, but it does. There's some nuances about it that I really have to stress, and I really want to be there with you so we can interact, and I can stress those things that need to be stressed with measures of center. Without further ado, let's get into measures of center. There are notes on Canvas in under Files, Unit 1. You'll find measures of center. You can use those notes. The homework I'm going to ask you to do are just the problems that follow the notes. I have like 3 or 4 problems after that I'd like you to try, and I'll look to collect that from you. Okay. And what was I going to say? Oh yeah, you might want to, if you'd like to, also reinforce this. Go in the textbook, has a pretty good section on measures of center. It's section 3.1 in our Pearson textbook, okay, that you can find on my lab. 3.1, okay, measures of center. So let's start with measures of center. A lot of times people call them averages, but we have to be really, as statisticians, we have to be real careful with the language that we use. We're careful about the symbols we use and careful about the language we use, because in reality, their average could mean 3 or more different things. Usually what people think of is, when you say the word average, they think of what's called the mean, okay? The mean for a set of data. And that's what people think of the average. Technically, it's called the arithmetic average. Okay, we really shouldn't call it the average because there are other averages. Okay, but the mean, and to get the mean, I believe all of you guys know that. It's where you just add up all the numbers and then you divide by the number of numbers. I think I have. Just a second. I got some numbers here I'm going to work with. Okay. So I got some numbers here, and all you really got to do is add up the numbers. What's 1, 2, 3, 4, 5? Add those 5 numbers up, divide by 5, and that's going to find the mean for you. And that's usually what people mean when they ask you to find the average. Okay, they're asking you to find the mean. All right, it's an easy one to find. Now I'll ask you that down below. Then the second one, which is often used, but you really can't tell when someone says average. You don't know for sure what they're using. Are they using what's called the mean, or are they using another type of average, which is called the median? Okay, There are times where the mean is more appropriate or the median is more appropriate, and we'll look at those. But the median essentially is just the middle number. For example, with these 5 pieces of data here, 1, 1, 3, what I got, 5, 9. You put the numbers in order from smallest to largest, and there I've got 5 numbers. It's easy to find. The middle number is this one right here. That's the median. Okay, that's the median, and that's pretty much all you got to do is find that middle number. But a little thing comes in that's with an odd number of pieces of data. If you have an even number of pieces of data, I just added another 10 at the end here. If you have an even number of pieces of data, the middle, is right in between here. Is in between the 3 and the 5. The middle of this data is between the 3 and the 5. So what you have to do if you have an even number of pieces of data, you just take the 2 numbers that are in the middle, 3 and 5, and you find literally the mean of those 2 numbers. So with 3 and 5, their mean is 4. So the median is 4. And that's how you do it if you have an even number of pieces of data. Sound okay? Yeah, you've got to take those 2 middle numbers and average them out. But in both cases, you want to put the numbers in order from smallest to largest before you do that. When I get back to school next week on Tuesday, cross my fingers unless I take a turn for the worst, I'm going to show you how to do all of these things on StatCrunch. I mean, for now, to find a mean, you can average, excuse me, now I start coughing. You can just add the numbers up yourself with your any little calculator and divide by the number of numbers for now. That's not practical if you have a list of 100 pieces of data. I've said this in class already this year, is if you've got 100 pieces of data and you start putting them in your calculator in your phone and try to add them up, more than likely you're going to make a mistake entering data. Okay? So I will show you how to find these different statistics using StatCrunch. Okay, so that'll be our first little lesson on how to use StatCrunch when I get back there on Tuesday. All right? But for now, for tonight's homework, for the homework I'm going to give you that follows the notes, you can just add the numbers up and divide by the numbers. Put them in order. I'd say put them in order and then add them up and divide by the number of numbers. Okay? And so I've got the mean and I've got the median covered. I want to point something out to you about the symbols we use. The symbols we use right here for mean, we use 2 different symbols. And this depends on whether you're talking about the mean for a population or the mean for data, for a sample. Okay, I've tried to stress so far, we got populations, we've got samples, we've got parameters, and we have statistics. The parameters come from the population. That symbol right there for the mean is actually an M, but it's a Greek small m. So it's pronounced mu, M-U. So we pronounce it a mu. So that's a mu, and that is if we're talking about a population, we use that symbol mu. If we say this data is sample data, we use this symbol for the mean, which is X bar. We read that one X bar. By using the correct symbol, you know whether you're talking about a population or you're talking about a sample mean. Okay, population mean or a sample mean. Okay. For median, we don't have a symbol. I mean, you'll see it abbreviated as MED or written as the word median. Okay, so there's no symbol for that one. Our third measure of center, is called the mode. Okay, mean, median, mode. Sometimes we say that. Mean, median, and mode. The mode is just the number that occurs most often in your list. And in order to get that, you do the same thing. You write the numbers in order, the data in order. Then you look which one occurs most often. Here we got 2 1s. The mode for this list is 1. Okay, So it's just the number that occurs most often. We don't often use the mode. There are times you want to use the mode, but we don't often use it. Okay, we're usually using the mean or the median, particularly in the statistics that we do in this class. But I can think of other times we'd want to use the mode. Now, that is if you got two. So right here I said the mode is 1. If you have two numbers that occur the same number of times, like for example, if I had another 9 here, I would have two modes. Okay, a 1, 1. I got 1 as a mode, and then if I had two 9s here, I'd have 9 also as a mode. And it's possible with modes to have more than one mode. Okay, so in this case, if I brought in a 9 here, the mode for that set of data is 1 and 9. We call it bimodal, meaning there are two modes. Okay, I suppose you could say trimodal, or I don't know what you would say after that. But I think if you have several pieces of data that occur the same number of times, usually we just say it's multimodal. Okay, so mean, median, and mode. They're pretty easy concepts. I think most of you have run into them somewhere in your life. But they're all examples of averages. Okay, so when you ask for average, when somebody asks you for average, your question should be, well, what average? Do you want a mean? Do you want a median? Do you want a mode? I'll show you another one in a moment. A mean, median, or a mode. Okay, it's not clear. And also when people are communicating with you on like on your cable network stations, they will often use the word average income. Okay, but they're not telling you whether it's the mean income or the median income, and they may be doing that deliberately. Okay, kind of to deceive you. I'll try to show you an example of that in a little bit. But yeah, you really do want to drill down and see, are they talking about medians or means? Yeah, like I said, it's not often we'll say modes. We will not often use modes. Okay? So my main focus is on means and medians today. Now, there is one more measure before I get into some of the details of means and medians. There's one other measure that it's not a good measure, but it sometimes is used as an average, and that's called the mid-range. Okay, the mid-range, like I said, is not often used. I probably won't ask you questions about it. It's just where you take your smallest number and your largest number, and you average those two. So take 1 plus 9. You take 1 plus 9 is 10 divided by 2 is 5. So the mid-range is 5. We don't use mid-range much. It's not really a useful measurement. But it is also another example of an average. I'm sure I know other ones. Okay? If you read the section in the book, they do a good job of talking about all these different measurements. Okay. So I had mean, median, mode, and mid-range. Now I want to go into some of the details of when you want to use the mean, when you want to use the median, when one is more appropriate than the other, and why. This is important. This is an important concept. Okay. And it has to do with, if I take a look at, I'm going to take that 9 out of my problem, and I'm going to change it to a 100. Okay? So now I got the data 1, 1, 3, 5, 9, 100. The last number here sure doesn't seem to belong to this set of data, does it? We call it an outlier. Just an outlier technically is defined as a piece of data that doesn't appear to belong to the rest of this data. Okay? Later on in a couple weeks, I will talk about kind of a mathematical formula that we use to identify outliers. But in reality, an outlier just is a number that doesn't appear to belong. It doesn't. It just doesn't fit the pattern of all this data. That 100 sticks way out there. We call it an outlier. Okay, I mentioned all these things in my notes. Okay, and in doing the homework, you'll get some experience with this. Now, what do you think that outlier 100 does in your calculation for your mean? Does that change? Does that change your mean by very much? Remember, the mean, we're adding these numbers together, and then we're dividing now by 1, 2, 3, 4, 5, 6. Now we're dividing by 6. If that number was 9 before, so it's not 100, if it's 9, we find the mean. But now if I take that last 9 out of there and I put 100 in there, an outlier, what happens to the mean? Okay, just imagine. I'm not asking you to calculate it here. I'm just asking, what do you think happens to that mean? Doesn't it take that mean and like yank it way forward? Makes it a lot bigger, doesn't it? It makes it a lot bigger, pulls it. So that outlier that's over here, this 100, takes the mean and like pulls it in that direction of the 100. Okay, it has a big effect. That outlier has a big effect on the mean. Okay, when we have a measurement like the mean in this example, where if there is an outlier, that outlier greatly affects the mean, which that 100 does, we call that measurement not resistant. Okay, it's not resistant. It's not a resistant measurement. Okay, remember that. It's in my notes, highlighted. It's not a resistant measurement because by putting that outlier in, it takes my mean and it pulls it. It does not resist that outlier. Okay, that outlier affects it a lot. It pulls it way over there. Okay, and so we say that measurement, the mean, is not a resistant measure. It's an important concept we have. But if we jump down to the next problem down here with the next set of data, and we look at the median. Oh, let's do the same set of data just so you can see. So if when I started out I had the 9 in there, with the 9 in there, my median ended up being what? 1, 2, 3, 4, 5, 6. That's 6 pieces of data. So it's between the 3 and between the 3 and the 5. So the median was 4. Okay. Now if I take that 9 out of there and I put the 100 in, so I've replaced just a normal piece of data with an outlier over here, an outlier on the right, on the right. Now what happened? What's the median for this set of data? There's 6 pieces of data. The median's going to be right in between here. Where is it? 3 and 5. So the median is still 4. Notice, by taking that value out and putting in this outlier, this extreme value, it hasn't changed the median. The median still remains the same. Excuse me. It might be that it slightly affects the median, and particularly if I have an odd number of numbers, it might slightly affect it. But an outlier does not have a great effect upon a median. Okay? It didn't change the median at all in this case. It remained 4. When I change that 9 to 100, the median stays 4. So we say the median is a resistant measure. The median is not greatly affected by these outliers. It resists the effect of the outliers, so we call it a resistant measure. So as we go through this beginning of the courses, I'm talking about different measures. We'll always talk about, are they resistant or are they not resistant? Because if you have outliers in data, your best measure for the center is the ones that use resistant measures. Okay, so in this case, my best measure of center is the median. Okay, if there's no outliers, could be the mean or the median. And actually, a lot of times people will use the mean. Okay, but if there are outliers in your data, you want to choose a resistant measure, so those outliers don't too heavily affect the value of the statistic. Okay, We want resistant measures. Okay. There's more. There's a lot more to that. But I'm going to hold off on that until I get there in person so we can interact when we talk about some of the other details, particularly of resistant measures and what effects they have on means and medians. Okay? But the bottom line is, if you have outliers, you want to choose, if you can, you want to choose a resistant measure. Okay? Because they are not greatly affected by those outliers. So we got mean, median, mode, mid-range, resistant measures, and non-resistant measures. Okay? And let me think. I think. Oh, come on. I think I've covered the topic now. It was an easier topic, measures of center. If you want a little more detail, a lot more examples, I read the section in the textbook. It looks really good. So I thought it was an easy read, so you might want to read through that. It goes into more detail than I went into here, but it doesn't cover everything that I want to cover. So there are some things about it that I want to talk about when I get there with you guys in person. Oh boy, as soon as I stop this, I'm going to remember something that I should be saying. I'm going to glance at my notes for a moment. I got them set up here to see if I forgot something. Find the mean, median, resistant. What is the... Nope. I think I covered everything I have to cover with those, believe it or not. I've covered everything that I've got to cover with measures of center. Okay, it's enough so that you'll be able to do the homework, which is on the bottom of the notes on measures of center. With that said, if anybody's got questions, email's not, in my experience, email's not the best way to answer mathematical questions. I am able to set up, and I would like to have used it for this, but I am able to set up a Google meeting. I like Google meetings because, you don't need to download any software or anything. I can just set up a Google meeting, and then I can send you a link. We can join it, and then we can talk face to face via a Google meeting. Okay, so if you have any questions that you can't wait until Tuesday to get answered, I don't mind. You can send me an email, and I'll set up a Google meeting, and then we can talk face to face instead of this one-way communication via a video. How does that sound? I sure hope all of you guys, none of you are experiencing this. I've heard some people with family members. I hope they're all doing really well. I feel for them. But I sure hope you guys are avoiding it. Yeah, might be we got to start wearing masks again or something. I don't know. Sure hope we don't go into that, what we had a couple years ago. Yeah, because I was living as if there wasn't COVID in the world. Yeah, I went to a Red Wings game on Thursday after class last week on Thursday. My first trip to Little Caesars Arena. It was incredible. I'd never been in there before. If you haven't been to a Red Wings game, and honestly, it was I was given the tickets by my brother. My brother was supposed to go with his son, but his son got COVID, so he couldn't go. And my brother had, for Christmas, had gotten 2 tickets, and they're really, really, really expensive tickets in Little Caesars Arena. So we had some of the best seats in the whole place. I don't know if there's a bad seat in the whole place. It's some of the best seats. That was really an incredible experience. I've never been in a stadium like that. So if you get a chance, go out and you haven't been to Little Caesars, I'd go to Little Caesars Arena. You don't have to buy those super expensive tickets like we did. But wow, just to see that arena, and yeah, it was actually a very good experience. I'm guessing that's where I caught COVID, because we had so many people all around us. I can't think nowhere else other than I was in class last Thursday. But but I haven't been anywhere else. My wife hasn't gotten COVID, so all I can think is it was on that trip too. My brother didn't get it, but I got it. So I'm guessing I got it at Little Caesars Arena. Can't say for sure, but I definitely am smiling a little bit. I'm feeling better. Wasn't too worried, but boy, was I beat up. But I'm getting better. So looking forward to seeing all of you. Next week, okay? Tuesday. I'm not a person who is absent very often. In fact, in my whole life of teaching, of 40-some years of teaching, I'll bet I haven't been absent 5 times. I just am not absent that often, and it's very frustrating. But I'll do my best. I probably would have dragged myself into school even this time, but not with COVID, because I'm not going to pass that on to anybody. I'm going to have to test negative twice before I can go back into school. That's the protocol now. I have those free tests that the government gives out. I hope everybody's got some of those, because all you got to do is write to them, and they give you 5 of those quick tests. And yeah, so I'd recommend if you don't have them, just write to the government. I think you can find them on the internet, and they mail them to you right away. Yeah, that's very helpful. Okay, let's call that quits for now. I'll put together an email, sending it to everybody with a link to this video. Everybody have a good weekend. Next week's gonna be warmer than this week, so that's good news. And everybody have a good weekend. All right, and I will be seeing you on Tuesday next week. All right, bye.